The first talk from my side called No Magic in SwiftUI. I try to break some magic stuff that's at least I sometimes feel in it. And I'm Dmitry Kurkin, iOS developer from Xamatic. Let's go. So that's the agenda. I mentioned these mysteries that I try to break around SwiftUI. Then we go through these blocks, how we actually build the application in SwiftUI, so main constructions here, and which optimization could appear on this place, how we could do optimizations based on unused properties in our states, and finally touch this quite relatively fresh macro observable, and what optimization could we have from it. So the mysteries. There is a lot of expectation from SwiftUI that it's really smart and it knows what's changed and do like really minimum updates based on it. And sometimes it could sounds kind of crazy. That's it. What we expect from it. And here, I mean, sometimes we expect that SwiftUI could update really small blocks that change it, even if you have like really big body. Maybe it could update something in the middle, like it's smart enough, who knows. Another thing that's, if you have the changes that's do not related, like you have a state, you have some like number of fields inside, and you do some changes and it could understand, does it really relate to the view? So should it really update something like render, recall like again bodies, or it's not related and we could skip it, like optimize. And here like it's also not so clear how it works and sometimes looks like a miracle. And the last thing that's also I heard about expectation from SwiftUI that if you have this state and inside the state some structure, in this structure another structure, anyway SwiftUI could understand anything, they could get the fields, understand what's really changed somewhere deep inside, and still like update only stuff related to it. So that's the miracle that I heard of like around SwiftUI, and I try to like break or explain them. So main blocks in SwiftUI. So this is like really simplest example of the view, and it's actually consists of two main blocks. Of course, it's the body, where all elements, like all the contents inside this view. This is like one main block here, and another like second block of the view, it's the constructor. So actually we could say that it has really two main parts. So when we construct the structure and actually the body, where we really create the content of the view. And actually with these like blocks, we could imagine like each stack, right? One element on it, like another element on it, and that's how we actually build the whole structure. But it looks like you have like this init inside the body, and it looks so straightforward that you could think that it calls one after another. So it's really like a function, right? So we start with an init, then goes to the body, from body to another init. So it's really straightforward. Actually, it's not really like this, like close, but not exactly. So if we take this example again, simplest view with some fields, we could like highlight again this blocks that I mentioned before. Then you could see that we have this body, right? This first block, and inside we actually call to these constructors. So we not call body from constructors, right? How it looks like in code, and you could imagine. But actually we do calls from body to constructors. So this actually the scheme how it works. SwiftUI do the call for the body in the cases when it thinks that it should. And inside the body we already this is our part. We call this, construct these other structures, other subviews, elements, control, and so on. So actually the body, the place where Swift calls the body, this actually optimization point where you could do these smart jobs, like decide, do we need to call the body, or this is the case that's like there is no changes and we could skip it this time. So like as I mentioned, with big function for body, if you have it this size, right, you have a lot of stuff inside, some if construction, some switches, could be really long. So you shouldn't expect that it could really update just a part of it, because this way it could break like the main idea of Swift. So you have some variables, they should have some values. You can just recall the part. So the only way to do it, like no magic, just recall body, do it, or not do it. Call the body or like skip it. If we come into this idea that optimization are about calling body or not, then let's look how actually, what the reason to have this change, when we should recall it, when it should be rendered and rebuilt. One of simplest case is the internal changes when we have some view, have the state, like this small example, right? We have the button that's do some changes of the state. So actually the changes comes from the view itself. So they like from internal change. In this case, our change actually limited to this view. It won't be, like in good case, it won't be visible from outside, and every changes would be limited to this scope. And like another case, of course, like kind of opposite. So we have some changes outside, like our parent was updated, and it also like rendered its body, recalls all these children, and then we get this call of our init, and probably that could be the reason to again render our part, like recall the body. But here, like, big question: do we really call it, or it could be skipped? And to skip it, actually, we could point this moment, like two moments. So as I mentioned in previous case, when it's internal change, then it's the limit of the scope, and then if somebody outside of our scope updated, then it's not related to us. And in case of external change, we could say that the change, the new version of the view, it's actually the same that it was before. So yeah, we created the new structure, located some new memory, but it's still actually the same view, and that's why we don't need to recall it. We don't need to render. This happened actually based on this stuff. We could say that the view is equitable. We could do it through this special kind of view, equitable view. There is like a function to make it like a bit more compact. And even for the view, we could add that it's satisfy equitable protocol and provide actually the operator that say is it equal or not. Yeah, and based on this data, we could decide either it's the same view or it should be like it says new some updates and we need to rebuild it. And here like a couple of links to get more details about this. So if you're interested, could read later. The presentation I'll add it to Slack and probably also on YouTube. Now, so we break this case about recalling the part of the body. So it's like body or nothing. And let's now go to this actually the properties, how these properties could update the view itself. So if there is like the story that's if the property is not used on the view, in that case, any changes of this property that won't actually change the state, and the body won't be recalled. So let's here consider like an example. I also like for this moment prepared kind of live demo. So I'll switch. I thought how could it be demonstrated on picture, and decided probably better I'll show how it works just on simple images. So here, this simple structure, like we have the text. I provide here the data to see if this is a really good example how to see the updates. So we do some changes and it reacts. You see the times changes and the number rises. So really simplest counter example. And so in that case, we changed this property, and this property is like used in our body, so like here. But also, it also could be moment like this. Here also, for me, kind of. Sorry. This is a bit demo of better version of Xcode.
If you make the font maybe 2 or 3 sizes bigger, it's hard to read.
Okay, just I'll try to change this comment.
As far as I know, you can just pinch and zoom it out.
Yeah. Now better? Yeah. So for me, there is also kind of it's used on the body. So I have one property, another property, so the changes should work in that case too. It sounds like no reason to skip it. But actually, if now I try to increment the counter, like do this action, you see that the time is not changed, like nothing happened. And the reason that it's actually hidden after another property. And like if we enable it, then it starts working. And here, like now we have like new version how to do this, but for previous one with like state and observable object, it's still probably valid. I think a lot of projects still have it, so this is not like really outdated stuff. So if you collapse it back, so it comes to the previous state, it's still working. You see that the time is rising, right? So this changes, it's like again on the previous state, but the value is rising. So the reason about this, that's actually the property that we use here. It's not the variables, not usual variable as it looks like, but it's this property wrapper, right? And this means that it's not just some value, not just some integer, but something around it. And it has, of course, this getter and setter methods, and that's where actually the magic happens. And magic actually comes to this part. If we touch this scatter method, then it creates some kind of subscription, like probably nobody knows what's really inside. We only could guess. But at this moment, it creates a subscription to get these updates for the view and start updating it. Before this first call, all the changes would be skipped. And like to demonstrate how it actually, like to prove it, if we use just the wrapper or like this harder variant with the wrapper value, then we actually use this getter method. But we also could touch just the state itself, like the object, the real object that's behind it, and in that case you could see that it won't change. And for this, I again have kind of demonstration here. So if we take it in the first case, you can see that it works. So you don't need to use it in any property, just mention it in the body, and it's already start to update to the view. If we use it in this variant, right, this magical moment when this preview works, so you can see that the time changes, I do the action and time changes. And if we directly touch the state object, in that case nothing happens. So the changes won't update the view. So that's how this optimization to skip the changes works actually. Okay, now we'll go back to the presentation. As it creates the subscription and it works the same time as we have the state alive, at this moment, this explains why it also doesn't work for observable object, because in case of state, we have something that's stored between the instances of the view. In case of observable object, we don't store anything, and that means that for any case we can't keep this information, and that's why for observable object it always reloads. I'd like to also demonstrate. I have for this also an example. So here we have now it is observable object, and also change some stuff inside, and you can see that it updates. Even we don't have any property inside, we don't touch it at all. Anyway, it updates the view. Go inside, go back to the presentation. Yeah, and finally, observable macro. So in case of this nice macro, we now need to change to the class, so declare our state as a class. Add this observable. We don't need any protocol, anything, and we don't need this published wrappers, and it starts magically working. In that case, works kind of better, because I mentioned this story when it creates a subscription and you can't remove it. Here, if you remove again the view, so it appears, it starts to create these changes of the recreation of the body, and if the property, if the element would be disappear from the hierarchy, in that case it's again stop update the view. This wasn't like this in the state, in case of state, but in case of observable, yeah, this works in both ways. So you could subscribe kind of and unsubscribe. Also, this story with subscription, as I mentioned, it worked only for the state, but doesn't work for observable, and in case of observable object. But here, for observable object, now we could use just without any additional wrapper, like just the variable. Put this type that we create with observable as a variable, and this works the same as observable object before. So it would change the view, but also with this optimization about kind of subscription and subscription. And yeah, it's in this class the properties that we have, they are kind of independent. If you use one and don't use another, this means that this second unusable property that still won't change everything. And the magic actually around it comes to this observable stuff, because when you first look at it, it looks like, okay, I created the class. Strange that it doesn't have any protocols, no nothing inside. So how could they actually do this magic? Because really simple stuff, simplest properties. So how do they get this update? How could I implement the same story? And yeah, of course, the answer is about observable, that it's not just a wrapper, not something around, but it's really this macro. It means that the class that you created, you write, it's not exist actually. Because at the end you have completely different type that's not how you see it in your code. So they actually could add some, like again, getters and setters for each property, and this way do these updates, subscription, all this stuff, or like to update the view. At the end, like with this macro, no magic. They show that with the macro, they really like this is like code from documentation. With this macro, they generate the code to these properties. Like they call it observation support, but probably it's something similar to setter and getter. Maybe the set, the get. Something like this, and use some static data to like do actually these updates. And like around the story, I would reference to the guys from OpsEO. They made really good example how it could be their own solution, how it could actually work. So I also recommend to read it and watch, of course. So in that case, also kind of demonstration. Yeah, I prepared. So here we have these properties again hidden after something. So when we don't have element, we don't have counter, right? Nothing happened. Time doesn't change. Now we show it. It starts to update the view, you can see the time changes, and now if we hide it again, then it stops again, so no changes. This is not how it was for the state. And a second example with this approach for observable object here, you use it like this without the state property, like property wrapper, just looks like a usual variable. And here it works the same way. So if we don't see the counter, we do the action. So the counter changes, but we don't see any change in the view. And if we show it, it starts to update the stuff. We hide it, and it stopped to update. And the last case here, it's about the understanding about the story that SwiftUI knows what's inside our structures. So if you have this observable and okay, it want the class from you, but maybe you prefer like the new way how to do it, like do structures everywhere, right? This value semantics and so on. So to have your state in the struct. So in that case, if you replace all content with your own structure, then it actually breaks this mechanic. So if you change the property one field in this structure somewhere inside, it means that the whole structure changes. And so if you change the count, it also affects like the whole state. And for this, I also do the demonstration. So the same like structure, only field one here, right? And now if we do the action, you could see that the time changes. So we actually do the updates. So no matter we like see it or not, it anyway changes the field. And we like can't optimize it as we did it before. So it changes anyway. And one more small thing here. If you try to go with this observable macro, usually there's no additional details, and also looked inside. It was like usual way how to get some insight from SwiftUI, get the declaration and look around. So I did it for observable, and I found this interesting field, observation ignored, and surprised that nobody mentioned in any documentation, any article. That's why I show you this for you here. So if you edit for one of the fields, in that case, the changes for this field would be ignored. So it could be also useful for some stories. So if the field is marked as observation ignored, you do the change, the view won't be updated. So it will react only like side effects. Yeah, and on this point, let's summarize what we have. So like all optimization that happens from SwiftUI, they are mainly around the body, would it be called or not. So to limit, like to decrease the calls of the body, you could limit the scope of the change. You could do this equitable views to again ignore like new versions. And do this skip of the changes in the field that's not really related to the view that you currently have. And that's all that I have for today, this session. If you have questions, I'll be happy to answer. Some questions? I won't go through the Mississippis. Okay. Yeah?
We check our state via environment object. Is this logic then working the same?
As I remember, environment also causes the updates of the view, and at least old environment, it also don't have this optimization from state. So is it something external for your view? It's stored somewhere. That means that it calls it the changes, but it can skip the field with this logic if it's not used. Yeah, and if we don't have any questions, then let's finish this. And I have like the pause, and after I think 30 minutes, I have another talk. So, thank you.